Hello all, I am Venkat Nagarani Bandaru, working as an assistant professor in Vishnu Institute of Technology. I am here to describing about the course called Operating Systems. Welcome to the world of operating system simulation, where digital landscapes come alive with the pulse of code and rhythm of processes. An operating system simulator is more than just a program. It's a great way to understanding the intricate dance between hardware and software that powers our digital devices. Imagine stepping into a virtual realm where you can orchestrate the flow of data, manage resources with precision, and witness firsthand the inner workings of an operating system. It's a playground for aspiring computer scientists, a canvas where creativity meets computation, and a tool that transforms complex theories into a tangible experiences. So, buckle up and prepare to embark on a journey through the heart of computing with an operating system simulator.
Yeah, hi, hello. In this video, we are going to represent the FCFS disk scheduling algorithm. Yeah, actually, FCFS disk scheduling algorithm is an first come first serve CPU scheduling. It is one of the simplest CPU scheduling algorithm used in operating system. In FCFS, scheduling the processor executed in the order they arrived, with the earlier arrival time getting the CPU first. In this mechanism, there are some of the 6 points called arrival of the process, selection of process, execution of process, completion of process, and context of switching. So we have doing this execution in the OS simulation tool. Open a command prompt. In this command prompt, we are writing some of the commands line java jar.gr. After that, after clicking enter, it will open a simulation tool. You have to select the OS sim. After selecting the OS sim, we have to create a separate file in this OS simulation tool. Select the FCFS disk scheduling algorithm. In this scheduling algorithm, we have to separately select some of the what are the burst times, statement times, selection process, step by step. How many you have to want for the selection process, like that. So later, after collecting some of the selected points like burst time, error time, like that, we have to execute it. So based on the FCFS disk algorithm, the simulation tool also in the disk shape model. So it will be rotate like this. After it will represent some of the graphs like that. So for rotating, it will represent the FCFS disk scheduling algorithm based on what we have given in the values. So it's creating a graph. It started from 3 to 4 like that. So it will be so it touches all the where we have mentioned the points. It will have to touch the points. So remaining one is the point, so it will touch it. So later it will represent in a graphical way. We have to stop. So there is nothing is there in the disk. So this is the scheduling process. So in this video, I'm going to explain about the FCFS CPU scheduling algorithm. So the difference between the FCFS CPU scheduling and FCFS disk scheduling algorithm is based on the disk. And I'm exam related to the both are same like that. In this FCFS CPU scheduling algorithm, the first come first serve scheduling algorithm is one of the simplest scheduling algorithm in the operating system. It schedules process based on the order they arrive in the ready query. The process that arrives first gets execution first, and so on, like that. In this FCFS CPU scheduling algorithm, there are some of the steps called error of process, selection of process, execution of process, completion, and context switching, and repeat. Again, we have to repeat. In FCFS scheduling, it's easy to understand and implement. However, it may not always be the most effective scheduling algorithm. One of its drawbacks is Conway effect. It is a main drawback in the FCFS CPU scheduling algorithm, where short processes might have to wait for longer process to finish, leading in ineffective CPU scheduling algorithm. In this algorithm, we have to take element like that one PID IDs, letter name, priorities, submission, order, time, and what we have to take in the CPU, it a default order. So based on the execution, what if the CPU percent is high, if the what is it will be top, later remaining 0.57, 0.3, 0.5, 0.157, it is in the descending order. So based on the what we have taken from the default value that have been stored in the voice simulation tool, it have been executed by the percentage CPU. So this is about the FCFS CPU scheduling algorithm. Thank you. Hi everyone, in this video I am going to represent priority scheduling CPU scheduling algorithm. So I am going to explain about the priority scheduling. Priority scheduling is a non-primitive or primitive CPU scheduling algorithm where each process is assigned a priority. Means some priority we have to be taken, some rules and guidelines have to be taken. The CPU is then allocated to the process with the higher priority among the ready processes. Process with higher priorities are given perform over process with lower priorities. So in this priority scheduling works, there are some of the steps: assignment of priority, selection of process, execution of process, context switching, that means primitive priority scheduling, data completion, and repeat. So the priority scheduling algorithm same like previous algorithm. So in this video, the IP ID have to be taken from us. We have to select order, name, and time left. We have to select multiples of PID IDs, orders, and times. Later, after selecting this ID, the data will be stored in the OS simulation tool. After the storing the data in OS simulation tool, we have to run this process. After running it, have executed some of the process and giving the result like shown in the figure. It will take what is the first PID means 5, later the name, the priority, and the submission, and the CPU and the response waiting. Later, what is the highest percentage in CPU? It will become first. Later, the ascending order like that. Later, PID 5, PID 2, PID 4 like that. Thank you. Hi, in this video, I am going to explain about the round robin CPU scheduling algorithm. So, we have, same like that, we have to open the simulation operation tool. We have to select the PID1 name submission and PID2 name submission. It will automatically store this data into the OS simulation tool. So I will explain about the what is the round robin CPU scheduling algorithm. So round robin CPU scheduling algorithm is a scheduling algorithm used for commonly for operating system. It designed to provide fair CPU time allocation among multiple processes by executing each process for a small unit of time, called as unit quantum or time slice. Here there are some of the steps: installation, selection of process, execution of process, preemption, context switching, repeat. The round robin algorithm ensures fairness of providing each process with an equal share of CPU time. It's suitable for time sharing systems while multiple users or processes need to be served concurrently. However, round robin may not be optimal for all scenarios as it can lead to high context switches overhead and may not be suitable for real-time applications with strict deadlines. Adjusting this time quantum can affect the balance between responsiveness and hold of round robin scheduling. So now we have selected different PIDs, names, priorities, submission, and period, response, working, and turnaround. So after that we can get the results in the percentage of CPU, how much percentage has been used in the round robin CPU scheduling algorithm. We can see the output in the screen. So like that we have to represent the round robin scheduling algorithm in this OS simulation tool. Thank you. The command java jar ossim.jar. After we click the enter, the OS simulation tool has been opened. Later we have to select the method, what we have to use in the method. Now we are using the algorithm like scan disk scheduling algorithm. So I would like to explain about the scan scheduling algorithm. Scan scheduling algorithm, also known as an elevator algorithm. In this disk scheduling algorithm used by operating system determines the order which to access disk blocks. It designed minimize disk R movements and reduce average response time for disk request. So this is the advantage for the scan disk scheduling algorithm. It reduces the average response time for disk request. So we have to, there are some of the steps we have to involve, we have to take care. So first step is regarding installation. The disk arm starts at one end of the disk as well as the outermost track or cylinder. Later the direction of the movement, servicing request, reversal and servicing request return trip. So the scan algorithm fairly to serve disk request by scanning the entire disk surface in both directions. So in this video we have seen that some of the times we have mentioned like 1 2 3 4 5 6. In this they are separated using the disk. So the black color rotator have to rotate all, it have to touches all the burst time, like that selection time. After the selecting we have to stop the process. So hi, hello. So in this video I'm going to explain about the SJF CPU scheduling algorithm. SJF CPU scheduling algorithm. The SJF full form is shortest job first. CPU scheduling algorithm is a non-primitive or primitive scheduling algorithm that selects the process with shortest burst time to execute time. The burst time is the amount of time a process required to complete the CPU execution. So in the same as remaining algorithm, SJF scheduling algorithm works with different types of steps. And the first one is selection of process, and the second one is execution of process, and the third one is context switching, completion, and again repeat. So this is the steps have been used in the SJF scheduling. Actually, SJF scheduling aims to minimize the average waiting time and turnaround time of process by selecting shortest job first. It's suitable for scenarios where the burst time of process are known in advance or can be accurately estimated. However, it may to stimulation for longer process if shorter process continuously arrived. So in this video we have seen that output of the SJF CPU scheduling algorithm. We have to take some of the PID IDs order like that. Based on the duration time the process will be executed like that. If the CPU percentage is more, it will be present in the top, later ascending order. So like that SJF scheduling algorithm has been implemented using the OS simulation tool in the operating system. Thank you. To open the command prompt and run the command java jar ossim.jar. After the enter we have to select the simulation tool. Later we have to select the what is the algorithm we have to prefer for this SSTF disk scheduling algorithm. So I want to explain about the SSTF scheduling algorithm. So SSTF is the shortest seek time first disk scheduling algorithm used in an operating system to determine the order in which to serve pending disk input-output requests. It selects the request with the shortest seek time from the current head position. So based on this, it has 5 steps. And the first one is initialization, selection of request, shortest seek time, servicing the request, completion. The main advantage of the SSTF algorithm is able to minimize the total seek time compared to other disk scheduling algorithms like FCFS, scan. But anyways, selecting the nearest request, it reduced the average seek time and improved disk input output performance. So it have to previous like FCFS scan scheduling algorithm based on like that only we have to select the burst time, selection time, like that. After we click the play button, the black color rounder have to touches all the points. So what will be the time will be taken for this touching the point, like that. So after that it will generate some of the what is the time taken for the point 1, point 2 and point 3, point 4, etc., like that. So the last one is taken the time more. After there is no like that, we have to stop the process and we have to see the graphs, like that. We have to implement the SSTF disk scheduling algorithm. Thank you. Hello everyone, in this video I am going to explain about the memory management techniques in operating system. There are 5 memory management techniques: contiguous memory allocation, non-contiguous memory allocation, virtual memory, fourth one memory protection, and fifth one is memory allocation strategies. In these memory management techniques, first type is contiguous memory allocation. It is classified in 3 types: single partition, multiple partition, and dynamic partitions. And the second contiguous memory allocation is paging segmentation. And the third virtual memory has 3 classifications: domain paging, page replacement, and page table management. And the fourth memory protection is classified into 3 types: read-only memory, you know the ROM, and memory segmentation and memory protection bytes. And the last 5th memory allocation strategies has classified into 3 types: first fit, best fit, and worst fit, bedding system, and slab allocation. In the video, we have represent that we have to select some of the PIDs: order 1, order 2, order 3, order 4. After the selection, we have to run the process memory management location. Based on the order and duration time, it will take some of the process and implement that in an order way. So it will represent some of the segmentations in the box wise order. So we have seen that output is running like that. So it will take in order 1, order 2 in order. Later it separates this segmentation. So memory management, we have selecting pagination. We have to run. After the completion of the pagination, we have to select the segmentation. So memory management techniques have so many types now. So we have selecting one step by step process. Like first one is virtual memory, like that, like segmentation. Later pagination, like that. So we can get the different values like that, different results. Thank you.